All right, so this is a video for section 9.5 in the text, and we're going to be using R quite heavily. So in this video, we're going to talk about an alternate way, well, actually two alternate ways of figuring out things like confidence intervals or correlations. So in section 9.3 and 9.4, we built up this theoretical framework using t-distributions and assumptions of normality to figure out, well, what's the confidence interval for beta hat, or what's the confidence interval for the expected value from the model? So now we're going to use a radically different approach to figuring out some of those, to answering some of those same questions. So why don't you pause, copy this panel down, and then press play. All right. And the second way we're going to do it is not going to be a surprise. We're going to use our resampling techniques to figure this out versus the more theoretical techniques we've used in previous sections of this chapter, okay? So we're going to use resampling to obtain approximations for standard errors, confidence intervals, as well as significant tests for linear regressions, okay? And we've had sort of two resampling techniques in this class, bootstrapping and permutation tests. And there's going to be a version for each of them. So in this panel, we're going to look at bootstrapping, okay? So we've got two variables. We believe there's a linear relationship between them, or we believe a linear model might tell us something about their relationship, okay? So we've got a data set of size n from a population with two variables. And what I'm going to do for the bootstrap process is I'm going to resample that original sample. So I'm going to grab n data points from that original set of n with replacement. And I'm going to keep my independent and my dependent, or my input and my output, my predictor, my response variables together. I'm going to grab n of them with replacement, okay? I'm going to build a linear model for that resample of size n and compute whatever statistic I'm interested in. Maybe it's the correlation, maybe it's the slope of the linear model, maybe it's the prediction, the expected value of the output given a particular input based on the linear model that we build. Whatever I'm going to do, I'm going to do that for that resample, and I'm going to record it. Then I'm going to repeat those first two steps, 10,000 plus times. And once I've got that, I've got 10,000 of these statistics recorded. I can view my bootstrap distribution to get sort of a confidence interval for that statistic, or the average of that statistic, whatever it's going to be, and I can inspect it for spread, bias, and shape, okay? So let's look at how that's done in practice. And we're going to use the skating data again. So the predictor variable is the score on the short program, and the response variable is what is their score on the free skate program, okay? So let's go to R, same old notebook. Okay, and I'm up here on section 9.5, lines 72 onward, okay? So I'm going to run this bootstrap 10 to the 4th times. I guess I should have said 10 to the 5th. Maybe that takes too long. And there's a whole bunch of different things I can ask R to look at. So I'm going to do a bunch of them. I'm going to create a vector to store correlations. That'll be core boot. I'm going to create a vector to store my betas. Those are my slopes. That'll be beta boot. My intercepts, those are my alphas. So I'll call that alpha boot. And the predictions of a free skate program, that'll be y pred, right? So I'm going to make those vectors so I can fill them up eventually. All right. Now my data set is the 24 scores I have, the 20 scores for the 24 skaters. They're short and they're free. And for each of the values from 1 to capital N for each of the 10 to 4 simulations, I'm going to sample n with replacement, okay? And then I'm going to create a bunch of things. Core boot, I'm going to record the correlation from that resample. Then I'm going to create a linear model and record my alpha, my beta, and my y prediction, assuming a short score of 60, okay? All right, so I need to assume that. So let's see, where was I? Let's go to here and run this thing. It's going to take a little bit. Cool. Okay. So let's look at the correlation first. The mean of correlation on line 92. The average correlation is about 84%. Standard deviation, about 5.7. And a 95% confidence interval for the correlations lands me between 0.7 and 0.92. I can create a histogram. And I can show you the observed correlation that's using the original 24 data points. There it is, vertical line. And then I can also do my predicted free skate program score if I scored a 90 on my shorts. That would be line 102, the mean. Y-pred, did I not? Oh, I might not have. Sorry, don't know if I did Y-pred. Okay, so let me run that thing again. There it goes, boom, 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 boom. Yeah. Y-pred.boot is not, oh, you know what? I've got to put capital P on there. Y-pred.boot. 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 See, I better save. And I better run. Now let's see if it's happy with me. Oh, there it is. So my mean free skate program score is a 111. Well, basically a 112. I've got a standard deviation. I can find a 95% confidence interval, just like we did in the last video with more theoretical setup. Okay. So my 95% confidence interval is 102 to 120. And I can't remember how close that was to what we've done before. What if I wanted to get information about beta, my slopes? Well, I can get the mean of my betas at 1.74, my standard deviation, and my 95% quantile interval for betas. I could also get a histogram, show you the observed one, and where my bootstrap comes in relation to it, okay? So I can do all this with bootstrapping as well as with the more theoretical modelings we had in the previous videos. All right. Well, now let's look at permutation tests. So again, I would pause, copy this down, and then press play. All right, so permutation tests are going to be a bit more limited. These are going to be to establish p-values, okay? So we're going to determine p-values for some statistics of interest, perhaps a correlation or the slope of our model, what have you, okay? So process. We've got our sample of size n, and we've got our predictor variable and the response variable and data points. And what I'm going to do is I'm going to draw a permutation resample of size n. And with permutation, it's without replacement. I'm going to draw those from the y's, keeping the x's in the original order. So what this means in practice is what we're used to. Let's say those were the original 3 data points. What I'm going to do is I'm going to take the y values and permute them. Permutation test. I'm going to permute their locations. So in this resample, it looks like I permuted the first 2 y values and kept the third one where it was, okay? So I'm going to do a resample. I'm going to compute some statistic that measures whatever the relationship is, correlation or slope, whatever it is, of the linear regression model that I create from this resample, and then record it. I'm going to repeat this 10,000 times, and then I can calculate a p-value, right? And again, let's go back to R and see that happening in action. All right, so here we're down in the section 9.5.1, the permutation test, all right? So we haven't done permutation tests in a while, but I'm going to run this thing 9,999 times. And it's going to refer to the number of rows in the skating 2010. So that's just grabbing how many data points I have. I'm going to create a result vector to store all 9,999 statistics. And what I'm going to look at is, oopsie-daisy, what I'm going to look at here, observed, is the correlation between the short score and the free score. Observed could have been the slope of my linear regression model, okay? So that's what I'm going to call my observed, the correlation. And the original data, the correlation is about 84%, okay? So a linear regression model, so linear regression is 84%. All right, so now we're going to run the permutation. I'm going to sample n without replacement, and I'm going to re-index the y values. That's what line 130 is doing, okay? So let me run this. Should go pretty quickly. And then I'm going to calculate a p-value. So correlation of observe was 0.84. So the correlation is strictly between 0 and 1. So I want to figure out the one-sided p-value. How likely is it that I could have had a correlation greater than 0.84? So I want my result to be greater than or equal to the observed. So I'm going to add up how many times I have a higher correlation, add 1, divide by n plus 1, and that's my p-value. And I get a p-value of 1 times 10 to the negative fourth, okay? So that tells me that that correlation value has statistical significance to it. It's highly unlikely it occurred simply by chance. So that there is a good correlation between the short score and the free score. Okay, so in the remainder of chapter 9, the remaining videos, we're going to apply this linear regression idea to data that's not necessarily linear, but that we can transform it until it is, right? So stay tuned.